Number 8. For the polynomial function f of x equal to negative 3 times x plus 4 times x squared minus 9, do the following. And this is a writing enriched question, so we'll make sure we use complete sentences for all of these. So for part A, we want to use complete sentences to explain how to find our x-intercepts and our y-intercepts, and then find them. I didn't leave myself enough room right here, so what I'm going to do is do it over here on my side. So to find our x-intercept, we're going to set our y equal to 0 and solve for x. And to find our y-intercept, we're going to set x equal to 0 and solve for y. So for these writing enriched questions, we're not looking for super detailed and elaborate. We just want you to use complete sentences to make sure that we know you know what's going on. Alright, so let's go ahead and find our x-intercepts and our y-intercepts. I'm going to do this over here. So 0 equals to negative 3 times x plus 4 times x squared minus 9. And we're going to use our zero factor property. So x plus 4 equals to 0, and x squared minus 9 equals to 0. So x equals to negative 4. And then x equals to plus or minus 3. So x equals to positive 3, and x equals to negative 3. Then we can go ahead and find our y-intercepts. So y equals to negative 3 times 0 plus 4 times 0 squared minus 9. So we get y equals to 108. Part B. Use complete sentences to describe whether the graph crosses or touches at each x-intercept, and explain why. Well, we're going to do this using the multiplicities of our x-intercepts. So the x-intercept of negative 4 has a multiplicity of 1, so the graph will cross the x-axis at x equals negative 4. The x-intercept 3 has a multiplicity of 1, so the graph will cross the x-axis at x equals to 3. And then the x-intercept of negative 3 also has a multiplicity of 1, so the graph will cross the x-axis at negative 3. Now I know you may be thinking for 3 and negative 3, there's a squared in there, so wouldn't it have a multiplicity of 2? Well, it does not. Because remember, the multiplicity comes from the power outside of our factor. So since the power outside of x squared minus 9 is 1, it's multiplicity 1. Then use complete sentences to explain the end behavior of f of x. We're going to need our parent function for this. And if you remember, our parent function comes from our leading coefficient times x to the power of our degree. So it's going to be p of x equals to negative 3 times x to the power of 3. And our graph will follow this same behavior. So under normal circumstances, an odd degree will have a shape similar to this. But with that negative, it's going to flip it. So it's going to be something kind of like that. So the left-hand side of my graph will go to positive infinity, and the right-hand side of my graph will go to negative infinity. So we should have to write that out in a complete sentence. So the parent graph of f of x is p of x equal to negative 3x cubed. So the left side of our graph will go to positive infinity, and the right side of our graph will go to negative infinity. Then it wants to use this information above to sketch the graph of the given function. So we're going to be plotting our intercepts and all of that good stuff and seeing where this takes us. Now the graph I have here has the y values already put in it, which is kind of an issue because our y-intercept, well, that was 108. So that's not going to work. So I'm going to go ahead and change my y values to 20, 40, 60, 80, 100, 120. And we'll just pretend like these aren't done down here. Cool. So I'm going to go ahead and plot my intercepts. So we had positive 3, negative 3, and negative 4. We know that the left side of my graph will shoot off to positive infinity, and the right side of my graph will shoot off to negative infinity. And we need to graph our y-intercept, which will be right about here. So starting at negative 4, we know that we're going to be crossing the x-axis. And we're going to be crossing the x-axis at negative 3 as well. And we're going to be crossing the x-axis at positive 3. So what it looks like here between negative 4 and 3, I'm going to slump a little bit and then come back up. And I have to go up. Well, that's going to bring us to our y-intercept. And then we have to eventually come back down for that last x-intercept. So there's a sketch of our graph. So our graph will look something like this. Of course, you want to get something that's more precise. We could fill in, we could evaluate different points on our graph to get the actual values. But again, we want to know the major parts of our graphs when we're sketching them out. So this is good enough.